We are on derivatives, page 51. Okay, so this says for 0 to t to 12, that interval from 0 to 12, particle is moving along the x-axis, okay, at certain times t. The velocity of the particle at time t is given by v of t, all right, which they gave us. V of t is equal to cosine pi over 6 times t. Okay, that is our velocity function. So they didn't give us the original function. They didn't give us the position function. They only gave us the velocity function. And that's okay. So it says in our question, when is the particle moving left? So what I have to go back and I have to remember is, all right, what tells me when it's moving left? All right, and that is when the velocity is less than 0. Yeah. So when the velocity is less than 0 or when the velocity is negative, then the particle is moving left. Okay, so that's what we're going to go through and we're going to try to figure out and we're going to try to solve. All right, so we're just going to see when is it 0. So I'm going to first try to figure out when is my velocity 0. So if I plug 0 in for the entire velocity, 0 equals cosine of pi over 6 times t. Okay, so what you have to do right here is think about what values would make that equal 0. Okay, so you have to know some things about your unit circle. Okay, so if you think about your unit circle, the cosine values on the unit circle, cosine values refer to which set of values, the x or the y? The x, okay? So when are my x values 0? There's 2 points on our unit circle when the x values are 0. Okay, this is 1 point where the x value is 0, right? And this is another point where the x value is 0. If I can draw, there we go. Okay, so we got to think about what are those things there. Well, this one's pi over 2. Correct? And the other one is 3 pi over 2, 3 halves. All right? So that's the two values that I need to be trying to make this part on the inside be equal to, because that will give me that 0 that I need. Okay? So let's think about if I take pi over 6 times some number, I need it to give me pi over 2. Okay? So think about 6 divided by what gives you 2? 3. So over here, what's it need to be so that when I divide it by 3, I get 1? What does t need to be? What divided by 3 is 1? 3. So doesn't it make sense that this is when t equals 3? Isn't that right? Correct? So it's equal to 0 when t is equal to 3. Can I draw it like that? Does that make sense to y'all? Okay. It also is equal to 0 for another t value. It's when it's equal to 3 pi over 2. So with the same reasoning, what is going to give me 3 pi? So 6 divided by 3 is 2. What number here divided by 3 is 3? 9. So that would be a 9 there. So we have figured out that when t equals 3 and t equals 9, the velocity is 0. So I'm going to write that down. Velocity is 0. Okay? So we're doing all of this to try to figure out when the particle's moving left. So we need to know when the velocity is negative. So what we're going to do is we're going to draw out an interval for ourselves. Do this in purple for the minor tigers here. Okay? So our interval is from 0 to 12, correct? All right. When t is 0 is when it's 3 and 9. So that is when, and I kind of just draw a little dotted line right there to let me know that this is my dividing point. All right, and the velocity is 0 there. So there's some kind of change in speed. Maybe we're slowing down and then speeding back up, or maybe we're going left and then going right again. So going from positive to negative. Okay? So what we have to do is we got to figure out some of these values in between what they are. So if I check like 1 in between 0 and 3, is that going to give me a positive or a negative value? And these are all time t. This is my time interval here. Yeah, so if I plug in 1 for t, okay, if you plug in 1 for t, that's pi over 6 times 1. So at pi over 6, the cosine value is positive, right? It's something over here. Pi over 6, your cosine value is positive because your x values are positive over here. Okay? Now I'm going to check in the middle. So I kind of have 3 sections, from 0 to 3, from 3 to 9, from 9 to 12. Now I'm going to check the middle section. Just pick a random number in here.
6.
All right? You want to try 6. Okay? It's directly in the middle. If you try 6, pi over 6 times 6 is 6 pi over 6. Which is just pi, right? So pi is located right on the x-axis. And what is my x value there, positive or negative? Isn't that on the negative hand side? That's actually a -1, right? So this is negative. Okay, and lastly, we're going to try something here. Okay, you try 11. All right, if you plug 11 in, you get 11 pi over 6. And 11 pi over 6 is all the way back around somewhere over here, right? And that is, again, where the x's are positive. Okay, so we have some information now to answer our question. Our question was, when is the particle moving to the left? So given off of what we have, when is our particle moving to the left?
Between 3 to 9.
Okay.
The interval 3 to 9.
Yeah, particle moves to the left. The left on the interval 3 to 9. Okay, or you could say from 3 to 9 like that. So there's 2 different ways that you could say this.
Oh, maybe we can understand this though.
So we had a great question, and the question was, when is the particle moving to the right? So if I had to answer that,
Between intervals 0 to 3 and 9 to 12.
yeah, so if it moves to the left when the velocity is negative, it moves to the right when the velocity is what? Positive. So
0 to 3 and 9 to 12?
yes.
Oh, okay.
Greater than 0, you move right. So you would say for the moving to the right-hand side, that is the interval from 0 to 3. Okay, and, or you could say union, all right, 9 to 12. Okay, so that's what we would say for that. So part C says to find the acceleration at time t, and once we do that, to figure out whether the speed is up or down or neither at t equals 4. All right, so to find the acceleration, we know that's just the derivative of the velocity.
So the derivative of the derivative.
So yes, all right. We know what v of t is. V of t is cosine pi over 6 times t. So to find a of t, we just have to take the derivative of that. So we're going to take v prime, which is also a of t. Okay, so I'm just writing both of those down for your convenience. So it is the derivative of cosine pi over 6 times t. So this is a little bit of some trig chain rule that you got. All right, so over here in my little thought bubble, I know y'all like my little thought bubbles. Okay, the cosine of whatever I got. What's the derivative of cosine of whatever I got?
Negative sign.
Yeah, negative sine of whatever I've got. Okay? Times the derivative of the inside, right?
Mm-hmm.
So that's kind of what I'm thinking about when I do this. So I've got negative sine of my blob of stuff in here times the derivative of my blob of stuff. Okay? So, that's going to help us. So this derivative is negative sine of my blob, pi over 6 times t, times the derivative of the inside. So what's the derivative of the inside of that function? Pi over 6 times t. If it was just 6t, what would you say?
6 and t would just be 6.
Yeah, so since it's pi over 6, yeah, it's just pi over 6. Okay, it's just a constant. That's a number over a number. So this would simplify to be our acceleration is negative, bringing the pi over 6 out front, sine of pi over 6 times t. Okay? So you have your acceleration at time t. Now, what the problem asks is something about the speed at a specific time. So it asks for the specific time of t equals 4, correct? So we're going to take t equals 4 and we're going to plug it into our acceleration and we're going to see if we get a positive or a negative value. That's going to let us answer the question about the speed. Okay? So I'm going to plug in a at 4. So that's negative pi over 6 times the sine of pi over 6 times 4. Are y'all okay if I just write 4 pi over 6?
Mm-hmm.
Okay. So now it goes to simplify and then look at my unit circle. So 4 pi over 6 is actually 2 pi over 3, right? So this is really like negative pi over 6 times sine at 2 pi over 3. So going back to my unit circle, the sine at 2 pi over 3, remember the sine value is the y value, if you send y, all right? what is the y value at 2 pi over 3? What does it say? So the sine at 2 pi over 3 is the square root of 3 over 2. So I can really stop here. My acceleration, is that going to be a positive or negative value?
I forgot how to find that. Negative.
Negative. Isn't it a negative times a positive?
Mm-hmm.
Yeah, I'm talking about after this one.
So here we have
Increasing.
a negative acceleration at 4. So the acceleration is negative.
Wait, so you should wait to the derivative of 2 pi over 3?
All right. So what we need to know now is we got to figure out if the speed is increasing or decreasing. Okay, speed increases. Speed increases when acceleration and velocity have the same sign. Okay, so same sign for acceleration and velocity. It decreases when they have different signs. Okay? So, at 4, what was our value here? Well, there's 4, isn't it? What was our value?
4 pi over 6, which is 2 pi over 3. Yeah, or square root of 3.
Wasn't it in the negative range? Okay, so here for our problem, v of 4 is a negative value. So v of 4 is less than 0. Okay, and a at 4 is also less than 0. So because they have the same sign,
Increasing.
all right, we say that the speed is increasing at this point.